Not going to go too deep in this video. This is just to show my new piece of gear that came in the mail today. I have not even plugged it in. The seller did have a picture of it displayed with it on, so I know at least that much works. It was sold as is, unknown, blah 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 blah. Got it for a good deal and couldn't go too wrong with that. This is a Sencore model LC75. It is a capacitor inductor analyzer. Some of you already know what it is. And we could check for leakage, check the value of the capacitor, we could check the ESR, and this here has to deal with the inductors, coils, yokes, flybacks, junk like that. And then over here is our voltage, which goes from 3 volts all the way to 600 volts. And no in between. We have on-off switch. Have a a caution indicator. I believe once you get above 3 volts, it'll start to blink. It's either 3 volts or 30 volts, it'll start to blink. Oh, right there it is, 25 volts. So once we get out of the blue into the red, it'll start blinking. We have control here to zero out the cables. I do not have the original Sencore cables for this. One day I will. But just for a single cable on this, it's like $70 or $40 or something like that. So I'll either buy one or I'll investigate into making my own. Not sure at this point. Have our BNC connector, and behind this is our fuse. And then we have our power on off. I think I identified this as power, but we clearly see that I suck. This is for testing. Let me get my finger out of the way so you could read. Up underneath here where it says pull chart, it's just that, a chart that needs lubricated. There we go. Here's a close-up of one of the charts. So you'll set your capacitor to printed value on it, and it'll tell you at what volts that your ESR should be at. So for example, if it's a 4.7 microfarad at say 25 volts, then your ESR should be 68 on the screen. The gray just tells you that has not been approved, or it's not a EIO standard or whatever it is. EIA standard. Still usable, but it's not an official number. So we got some pretty pictures there. Probes, tells you how to use the device. Now while I was waiting for this to be shipped to me, I did download the service manual, and I thumbed through the whole manual, read the instructions. It's kind of cool, does some things that I didn't even know it could do. What they are, I don't know, I can't remember. I just remember it was kind of cool. This meter came out in 1987, and I believe it sold for right around $1,000. And they still demand a pretty penny these days just the same. And there's what it covers in capacitance and in microhenries. And microhenries are for coils. We have a really nice clean display. This thing don't even look like it's ever been wiped down. Up underneath you can see it's all that in a bag of chips. This is a really nice clean unit. It's a big unit. It's smaller than my Sencore DMM, but it is about the same equivalency to my Sencore FC45 frequency counter. So if you have one of those, you know how big this is. We have label up top, a really stiff handle, on the back here we've got the power cord, and then this right here is an adapter. I only know that because that's what I read. And we have a string where the Sencore tag was at. This as I was saying, this right here is a adapter. You stick the probes into it, and then the alligators will allow you to clip onto big lug capacitors. Here's a close-up of what that looks like. A lot of these meters, I don't recall seeing this adapter. Most of them they're missing. And speaking of missing, I am missing the tool that goes up here, and that's just basically a little bar that goes between the handle and the button to allow you to reform a capacitor. Down here we've got sticker, tells you where your calibration controls are at. Let's go ahead and plug it in and see what it looks like. I've got it plugged into mains, and I have a propagator clip plugged in. As stated, I've not turned this on yet. This will be maiden voyage. That looks really good. I don't remember how it said to zero out the meter, but I do have it reading 000. I've got some capacitors from a earlier project, and then I've got that big capacitor there. That big capacitor is the capacitor that I pulled and replaced out of the frequency counter. That was the mains power supply. Let me get one hooked up and we'll try the meter out and see what it does. Okay, reading the manual, what it says to zero out the cable is you short the leads out, and I'm probably not going to be able to do this while holding the camera, so I might have to do this off camera. So you short the leads together, you push the inductor value button, and then you zero out the meter, and we need to get to 0.0.0 or 00.0. Hey, maybe my cables will be good enough. What it's looking for is a low capacitance cable. Oh, cool. Well, that'll save me 60 bucks. Let me put a capacitor in line. Well, I got a little excited there. I should have finished reading the rest of the instructions. Anyway, there's more steps to zero this out. One of the steps is you got to go to the rear panel and calibrate back there. I did not do that. I'll do that later after this. This is just an initial testing of demoing, showing the meter. This capacitor here is 1,000 microfarads at 25 volts. Now, you want to ensure that you don't have that touching you, because you're about to put 25 volts into it and that could zap you. I worked on a monitor a couple of days ago, and this is a capacitor that came out of it, so we're going to check that. So we're going to put this up on 25 volts. And we'll check for leakage. And it's by my foot, so hopefully it won't blow up. Alright, so it says hold for about 3 seconds. Should get a stable number. If it don't, then that capacitor has issues. 1001, 1002, 1003. Nope, issues. Alright, so we said 1000 microfarads, so let's push the value button. Alright, no value. Let's push the ESR. So that's showing us a negative 1.77 ohms. I'm not even going to look that up on the chart. I'm pretty confident that that is a resistor. That is no good. Alright, this capacitor is a 680 microfarad at 35 volts. And we could definitely see visually it does have a problem. Alright, so 680 at 35 volts. We'll leave it at 3 volts. We'll hit the leakage. Nothing. Let's go to value. Nothing. And our ESR. .45 ohms. Now, one neat thing about this meter is you can test capacitors and inductors in line. Alright, so I've got the big capacitor plugged in, hooked up, and as you see, that's 10,000 microfarads, and it's at 15 volts. Again, this was the line filter for the Sencore LC75 frequency counter. I'll set this one aside. That might take a moment for it to reform. Got this down to 3 volts. And let's do our leakage. And I'm at 3 volts on the setting. One thing the book did say is if the capacitor has sat on the shelf for a while, it'd probably be best to reform it for about 15-20 minutes, I believe. I forget where the number is we're supposed to be at there. Let's go ahead and hit value. I'll have to do more research or read the book again to see where leakage is supposed to be. Could also be in my settings, my paperwork here. Alright, so that was a 10,000 microfarad. And we're showing 11,600. I think we may be in the good. I'd have to read what the capacitor says for percentage. But then again, we are only at 3 volts. So let's go ahead and go up to 10 volts. Leakage. Let's do value. Alright, let's do the ESRs. Alright, so negative 170. One other thing I wanted to mention was when you release the buttons from testing, it'll automatically discharge the capacitor, so it puts it at a safe state. So hopefully you don't zap yourself. Anyway, that will end it for this video. Thanks for watching. Hope you enjoyed.